So we're going to review a few things about vectors. First of all, vectors are a mathematical tool used to represent physical phenomena. In our case here, it's mostly going to be representing forces. And even though forces should be measured in newtons in the curriculum, we're going to use pound forces. Okay. So it is represented by an arrow. So you can name it with a simple letter, or you can name the starting point and the end point, and name it with them, drawing an arrow over them. Not like a line, but just a simple arrow like this one. Okay. So this will be the vector AB. Now the vector AB is, or any other vector, is defined by its magnitude, which is essentially its length. In our case, it's going to be the force measured in pounds, and its direction. And the direction can be either measured from east, west, north, south, or as an angle measured from the horizontal axis. Okay. So if I write theta for the angle right here, then theta would represent the direction of the vector. Okay. The vectors also have coordinates, and the coordinates of the vectors are essentially the distance from the point A to the point B in the x direction. So in the x direction, right here, we are going to have the x coordinate of the vector AB. And in the y direction right here, we are going to have the y coordinate of the vector AB, and it's written as AB and brackets. They're not parentheses, they're brackets like this. And we're going to have a number right here, another number. So I'm just going to write it as XAB and YAB like that. Okay, go fast. We'll go into examples later, but for now it's just a quick review about vectors. Another important component of performing solving problems with vectors involve going from the coordinates to the direction and magnitude. And so if you have the angle theta right here, and the magnitude of the vector u like this, written as u with double bars on either side like this, we can say that the x coordinate of the vector u is equal to the magnitude of the vector u times the cosine of the angle, and the y coordinate of the vector u is equal to the magnitude of the vector u times the sine of the angle. So you use this formula if you want to know the components of the vector u, the coordinates of the components, knowing its magnitude and direction. And if, on the other hand, you have the vector that is defined by knowing its x coordinate or x component and y component like this, then you can say that the magnitude is equal to the square root of its x component square plus its y component square, essentially the Pythagorean theorem. And the angle theta, the direction, always measured from the horizontal axis, will be the arctangent of the ratio of the y coordinate over the x coordinate. Okay? And that's it for this little introduction. We will have another video involving an example.